In the name of Allah, the Beneficent, the Merciful. Welcome to the world of biophysics. Due to coronavirus, we have to continue our online class. I would like to suggest you stay home, stay safe. Coronavirus safety. Follow these easy steps to help prevent the spread of COVID-19. At first, the first step is disinfect surfaces around your home and work. Number 2, wash your hands for at least 20 seconds. Number 3, sneeze or cough, cover your mouth. Welcome to our online class. I am Mohammad Muqtadir Hossain Bhuiya, lecturer, Department of Physics. Observe following diagram and observe this diagram too. What you have observed? Okay. We are going to discuss about the chapter vector, and today's topic is understanding vectors and mathematical operations of vectors. Key points of this chapter is scalar, vector, unit vector, zero vector, vector component, addition of vectors, subtraction of vectors, triangle law, parallelogram law, and dot product. Learning outcome. By the end of this lesson, you will be able to explain the idea and property of vectors, explain the different physical quantities of physics as vector, explain the addition and subtraction of vector, explain the geometrical vector addition law and parallelogram law. Scalar and vector quantities. The physical quantities which is satisfied some property like magnitude is scalar quantity. For example, length, speed, work, mass, and density are the example of scalar quantities. And vector quantities refer to the physical quantities characterized by the presence of both magnitude as well as direction. For example, displacement, force, torque, momentum, acceleration, velocity are the examples of vector quantities. What are vectors? Okay, if you want to reach a place and with the help of a person, you can ask him, can you tell me the distance to this place? Or you can ask him, can you tell me the direction to this place? Which question is more preferable? Of course, the second one. If you want to reach this place, you have to know the direction and the distance. Without any of the information, you cannot reach this place. And the quantities, the distance is scalar quantities and completely described by their magnitude. Here, the example mass or the size of any ball or the area or the volume are the scalar quantities, like and distance, temperature, and the speed are the example of scalar quantities. Because if you want to describe these quantities only with magnitude, that's why this is the example of scalar quantities. And if you want to describe this any of the quantities with the help of magnitude and direction, and the quantity will be vector quantity. Like the force applied to any object is the vector quantity, because to understand force you have to know the magnitude and the direction. Here the example of the flow of air to any certain direction is the example of vector quantity. If you want to describe the speed of velocity of air, that's you have to know the speed and the direction. For example, the speed of air is 30 km per hour in northeast direction. Here the direction is northeast and the magnitude is 30 km per hour. You have two information like magnitude and direction. That's why it is vector quantities and completely described by their magnitude and direction. Basic concepts about vectors. A quantity that has a magnitude and direction is called vector. Observe this line segment. Is it a vector? Here from A to B, it is shown the length nor direction. If it is directed with an arrow, then you can call it as a vector because the direction is from A to B and the line segment is only shown the magnitude. Here the vector can be denoted by AB with an arrow in the upper side. Here the vector start from the point A and the point A is called initial point, and the vector AB with the terminal point, and here the terminal point is B, and the magnitude is from A to B, and the length of the length of AB is magnitude and the direction is from A to B. If the direction is from B to A, then this is also called vector, and the vector is BA. Here the initial point is B and the terminal point is A, and the vector is BA, and the magnitude of the vector BA is modulus of BA. Here the magnitude is same and BA is equal to AB. The magnitude of BA and the magnitude of AB is same, but the direction of the first vector is from A to B and the direction of the second vector is from B to A. Here, cause here we have another example of vector. Observe these two curves, and the velocity of the first curve is v1 and the velocity of the second curve is v2, and the velocity of the first curve is 40 km per hour towards east direction, and the velocity of the second curve is 80 km per hour towards north direction. For a vector, you have to know the magnitude and direction. Vector quantity is D, and the line segment is from A to B. Here, to know the direction, observe the arrowhead. These are the example of scalar and vectors.
Vector? That's right. Previously, we had seen that a vector is a quantity that has magnitude as well as direction. For example, let's say an object is displaced from a point A to a point B, which is 3 meters away from it, in a direction 20 degrees east of north. So here, the displacement of the object is a vector quantity. The magnitude of the displacement vector here is 3 meters, and its direction is 20 degrees east of north. As we saw earlier, we can represent a vector by an arrow. So the displacement vector is represented by an arrow with its initial point as A and its terminal point as B. It's denoted like this with an arrow above the letters. Or we can also denote it by a single letter like this. The length of the arrow represents the magnitude of the displacement vector, which is denoted like this. And the direction of the arrowhead represents the direction of the vector. So we see that we can represent a vector in general by an arrow. Now here are a few vectors on the screen with different magnitudes and directions. Notice that these vectors are parallel to each other, while these vectors have a common initial point. Now, obviously a question arises in our mind. Can we compare two vectors? Or when can we say that two vectors are equal to each other? In this video, we will understand this and we'll also look at different types of vectors. First, let's consider these vectors. We can see that they all have a common initial point O. Two or more vectors having the same initial point are called coinitial vectors. So here, vectors OM, ON and OL are all coinitial vectors. Now consider these vectors. Here, they're all parallel to each other, or we can say that they are parallel to this line. If two or more vectors are parallel to the same line, even though they have different magnitudes and directions, they are called collinear vectors. Thus, all these vectors are collinear vectors. Now consider vector AB and vector CD. They both are directed in the same direction and have the same magnitude. So we can say that vector AB is equal to vector CD. Two vectors are said to be equal if they have the same magnitude and direction regardless of the position of the initial points. Notice this important point. It tells us that it's insignificant where the initial points of the vectors are if they're equal to each other. So according to this, we can move a vector parallel to its position without affecting its magnitude and direction. For example, we can make two copies of vector AB by moving it parallelly in this direction or moving it in the same direction like this. Here, all the three vectors will be equal to each other. Such vectors are called free vectors. That is, parallel displacement of vectors gives us equivalent vectors. One advantage of this is that it makes it easier to compare two vectors. Now consider the vectors AB, RS and UV. Let's move them parallel to their positions without affecting their magnitudes and directions such that they originate from a single point. Can you see? Now it's much easier to compare the directions and the magnitudes of these vectors with respect to each other. Now let me ask you a question. What will be the negative of a vector? For example, let's take the vector CD here. We know a vector is defined by two things: its magnitude, that is its strength, and its direction. So the negative of the vector CD is a vector which has the same magnitude as that of CD, and its direction is opposite to that of CD. So vector DC will be the negative of the vector CD, and it's denoted like this. Also notice that vector EF will be the negative of vector CD. Yes, the magnitude of vector EF is the same as that of vector CD. And it's directed in the opposite direction to that of vector CD. So vector EF will be the negative of vector CD. Thus, we saw here when are two vectors equal to each other, and also what's the negative of a vector. Now can you tell me if we can add two vectors? Does this seem possible to you? We will see this in the next lesson. To stay updated and to keep learning such interesting things, Do subscribe to our channel.
Yes, by now we're very well acquainted with the idea of representing a vector by an arrow. Its length represents the magnitude of the vector and the arrowhead the direction of the vector. Now moving on, we're going to look at an interesting concept called components of a vector. To begin with, instead of diving right into the concept, let's first intuitively understand what is it all about. We know that any natural number can be written as a repeated addition of the number 1. 2 can be written as 1 plus 1, which is 2 times 1. 3, 1 plus 1 plus 1, that is 3 times 1, and so on. So any natural number is just the number 1 added to itself a few times. Similarly for vectors, there exist some special vectors similar to the number 1. These vectors, I hat, j hat, and k hat, are some examples of them. In the three-dimensional space, they act like the number 1 for different directions like this. So for example, suppose we have a vector A in the 3D space. Then it can be decomposed into addition of these vectors like this. Don't worry about what all these symbols mean. We will understand them in detail. But for now, the point is that, similar to the natural numbers, a vector can be decomposed into a set of special elementary vectors. For example, consider another vector B in three-dimensional space decomposed as this. Basically, we can say that these two examples tell us that any vector in a 3D space is just made up of these three vectors. Here, these individual vectors are called the components of the vector. The thing is that, as we learn more about vectors, we will see how important and useful this idea is. It makes dealing with vectors a lot easier. For example, suppose we want to add these vectors. Then we will see that to get the resultant vector, we just have to add the components of the vectors like this. Interesting, right? These components makes the addition of vectors as simple as adding numbers. This was just a glimpse of the whole idea to show you the bigger picture. Let's move ahead and understand what exactly the components of a vector mean. For this, we'll start by understanding what these special vectors are. These are called unit vectors. Consider a vector C represented by this arrow. Now let me ask you a question. What if we multiply this vector by this number 1 over magnitude of vector C? Can you tell me what would be the magnitude and direction of this vector? Okay, let's see. Remember, we have seen that multiplying a scalar lambda, that is a number lambda, by a vector A gives us a new vector. The magnitude of this new vector is equal to the absolute value of lambda times the magnitude of vector A. And its direction is the same as that of vector A if lambda is a positive number, or opposite to that of vector A if lambda is a negative number. So let's look at our question again. Here we multiply by the number 1 over magnitude of vector C. So the magnitude of the new vector will be this, which turns out to be 1. And since the number is a positive number, the direction of the new vector will be that of the vector C. So we get a vector with magnitude 1 in the direction of the vector C. This vector is called the unit vector in the direction of vector C. It's denoted by a symbol like a hat above the letter pronounced as C hat. Let's represent it like this with arrow. So a unit vector is simply a vector whose magnitude is equal to 1. This speciality of the unit vector is that it just specifies a particular direction. Therefore, the advantage of a unit vector is that we can use it to express any vector which is along its direction. Let's take a few examples and understand this. Suppose we have these two vectors D and E directed in the same direction as that of vector C. Now consider the vector magnitude of vector D times the vector C hat. As the magnitude of vector c hat is 1, the magnitude of this vector will be equal to that of vector d. And since the vector c hat and d are directed in the same direction, the vector d will be equal to this vector. Similarly, vector e will be equal to the magnitude of vector e times the vector c hat. And here as well, we could write the vector c to be equal to the magnitude of vector c times the vector c hat. So now the idea of a unit vector is very clear to us. But we still have to understand what component vectors actually mean. Let's see that in the next lesson. To stay updated and to keep learning such interesting concepts, do subscribe to our channel.
boat is crossing a river from one bank to another. It's moving in the direction perpendicular to the flow of the river. Tell me, will the boat reach the bank at this place P or somewhere to the right of it? That's right. The boat will reach the bank somewhere on the right side of this point P. We know that the motion of the boat is also influenced by the velocity of the river along with the velocity of the boat's engine. So, the boat actually travels with a different velocity, which is the resultant of these two velocities. If vector v1 represents the velocity of the boat's engine and vector v2 represents the velocity of the river, then the boat's velocity v3 will be the vector sum of these two velocities. And what will be this vector v3? Let's find out. Let's say this arrow represents vector v1, the velocity of the boat's engine. We know that the river's velocity is perpendicular to v1. So let this arrow represent the river's velocity v2. Now we know intuitively that the vector v3, which is the boat's actual velocity, will be somewhere in between these two vectors. But how can we find it accurately? Actually, to find the vector v3 precisely, there is a law of vector addition called the Parallelogram Law of Vector Addition. Now let's suppose that we have a parallelogram, and the two adjacent sides of it represent the two vectors A and B in magnitude and direction like this. Then the sum of the vectors A and B is represented in magnitude and direction by the diagonal of the parallelogram through their common point. This is known as the Parallelogram Law of Vector Addition. Take a moment and have a look at it. Now let's get back to our example. Can you apply this law here to find the boat's actual velocity v3? For this, let's draw a line segment parallel to vector v1 here and similarly a line segment parallel to vector v2 here. So since v1 and v2 are perpendicular to each other, we get a rectangle here. Now, according to the Parallelogram Law of Vector Addition, this diagonal will represent the vector v3. We can find the magnitude and the direction of the vector v3 by using the geometric properties of this rectangle. So, in this way, we can apply this law to find the vector sum of two vectors. Now suppose we are given these two vectors C and D whose initial points are not the same. Can you find their vector sum? For this, we will just have to move one of the vectors parallelly without affecting its magnitude and direction such that the initial point of both the vectors coincide. If we move vector D, then we will get this. Now we draw two lines parallel to vector C and D to form a parallelogram. Then, according to the Parallelogram Law of Vector Addition, this diagonal will represent the sum of the vectors C and D. But now wait. In the previous video, we saw that the sum of two vectors is given by the triangle law of vector addition. Here, according to this law, we move vector D such that its initial point coincides with the terminal point like this. So we see that these 3 points, A, B, C, will form a triangle. Now the third side of the triangle in the opposite order than these two represents the vector sum of these two vectors. Thus, we have two laws for vector addition. Which one should we follow to find the vector sum? Actually, both the laws give us the same resultant vector. These two laws are equivalent to each other. We will see this in the next lesson. Here, we saw how to add vectors. In the next lesson, we will also look at how to subtract two vectors. To stay updated and to keep learning such interesting concepts, do subscribe to our channel.
Now find the resultant and direction of parallelogram with the help of this diagram. Here P is a vector and Q is a vector, and both started from the same initial point A, and with the help of diagram we can say that the vector P plus Q is the diagonal of this parallelogram, and it indicates the resultant and direction of this parallelogram. Statement of parallelogram law is if two vectors acting simultaneously on a particle are represented in magnitude and direction by the two adjacent sides of the parallelogram drawn from a point, then their resultant is completely represented in magnitude and direction by the diagonal of that parallelogram drawn from that point. Here, two things important. That is, two vectors acting simultaneously on a particle, and their resultant is completely represented in magnitude and direction by the diagonal of that parallelogram. Here, from parallelogram law, we can calculate the value of resultant, that is R is equal to root over of P square plus Q square plus 2PQ cos alpha, and the maximum value is R is equal to P plus Q, and the minimum value is R is equal to P difference of Q, and the direction is tan theta is equal to Q sin alpha divided by P plus Q cos alpha. Here direction with either vector is equal to the opposite vector into sin alpha divided by same vector plus opposite vector into cos alpha. The equations of this chapter is these are the equation. This help of this equation we can solve the mathematical problems of this chapter. And now we are going to discuss about the vector multiplication. There are two type of vector multiplication. That is one of them is dot product, and another one is cross product. Here now we are going to discuss about scalar product or dot product of two vectors. The definition of scalar product is the definition is product of their magnitudes multiplied by the cosine of the angle between the vectors. Here x dot y is equal to xy cos alpha, and this is the diagram. For dot product, there are two ways to multiply two vectors. The dot product produces scalar quantity. It has no direction. It can be pretty easily computed from geometry. It can be easily computed from components. Here v dot w is equal to vw cos theta is equal to vx wx vy wy plus vz wz. The dot product of two unit vectors is easily can be calculated, and here there are some value like I dot I, j dot j, k dot k is equal to 1, and I dot j is equal to j dot I is equal to 0, I dot k, and k dot I is equal to 0, z dot k is equal to k dot j is equal to 0, and dot product is commutative. That's why I can write v dot w is equal to w dot v. Properties of dot product. These are the properties of dot product. Here u dot v is equal to uv cos theta, u dot v is equal to v dot u dot v is equal to 0 when u and v are orthogonal. That is, the angle between them is 90 degree. 0 dot 0 is equal to u, v square equal to v dot v. U dot v is equal to au dot v, and au plus bu dot w is equal to au dot w plus bv dot w. And knowledge based question from this topic is what did, what does vector dot product mean? Dot product is the product of magnitude of two vectors with the cosine of the angle between them. Geometrically, it is also be equal to the product of projection of magnitude of one vector on the other and the magnitude of the second vector. What does a dot product of zero mean? A dot product of two vector is the product of their length times the cosine of the two angles between them. If the dot product is zero, then either the length of one or both is zero or the angle between them is 90 degrees. What is the dot product of I and j? In words, the dot product of I and j or k with itself is always 1, and the dot product of ij and k with each other are always 0. Now, comprehension based questions. Explain dot product with example. The dot product between a unit vector and itself is also simply to compute. In this case, the angle is 0 and cos theta is equal to 1. Given that the vectors are all of length 1, the dot products are I dot I, j dot j, k dot k is equal to 1. Examples. Here the examples are: mechanical work is the dot product of force and displacement vectors. Power is the dot product of force and velocity. Here for you, I have a creative question. Here a is equal to 2y plus 2j minus k and b is equal to 6i minus 3j plus 2k are two vectors. At first, the question is, what is vector product? All of you know the definition of vector product. The scalar product of two vectors maintain the law of distribution. That is, previously we have seen that u dot v is equal to v dot u is the example of a commutative law, and the distributive law is a dot a into u dot v is equal to au dot av is the example of here we have distribution law. By using distribution law, we can write the scalar product that is a into u dot v is equal to au dot av. Now the question is, find the addition and subtraction of two vectors. Here to add a and b, we have to add with the quantity 2y with 6i, and we have to add 2j with minus 3j, and we have to add minus k with 2k. Now the question is, justify the mathematical conditions of the two given vectors to be perpendicular and parallel. To check this mathematical condition, we have to make dot product with a and b, and we know that a dot b is equal to ax bx plus ay by plus az bz, and by using this equation we can calculate the value of a dot b. If the value of a dot b is equal to 0, then we can say that it is the two vectors that given is perpendicular, and if we calculate the cross product of a and V, that is A cross of V. If the value is 0, then that's why you can say that the given two vectors are parallel. The thing is that if the dot product is 0, then the vectors are perpendicular. Two vectors are perpendicular, and if the cross product is 0, then two vectors are parallel. MCQ based on this lesson, the resultant value of A and the opposite vector of A is 0. The resultant value of two vectors will be maximum if the angle between them is 0 degree. Home task for you, observe this diagram. And the width of the river is 1.5 kilometer and the velocity of water current is 4 kilometer per hour. Boatman Abdullah rows his boat along AV and bridges to the opposite side of the river along AC. The velocity of the boat is 3 kilometer per hour. First question is, what is vector quantity? Second question is, a reciprocal vector can be said as collinear vector. Explain. Determine the distance traveled by boat along AC. Will the boatman be able to reach at point B rowing his boat along AD? Express your opinion by mathematical analysis. Do you have any question? I think you may have some question regarding to our lesson, and I'll be available in our class time. If you have any question, then ask me in our class time. Thank you all. Stay home, stay safe. Hope that the coronavirus may not affect us. May Allah save us all.